Hello and welcome back to Calculus 1. This is the last lecture in Calc 1. We are going to talk about U sub, short. Full title is Integration by U substitution. It doesn't have to be U, you can use any other letter. I don't know, for some reason U is standard, so we're just going to use that. I will start with integral of x plus 3 squared dx as a review. The way to do this integral could be to expand the binomial, get x squared plus 6x plus 9. Don't forget the parentheses. And then integrate each term as x cubed over 3 plus 3x squared plus 9x, and then plus c at the end. So x squared was x cubed over 3, x went to x squared over 2, but 2 and 6 canceled, and then 9 went into 9x. So you see that you had to expand. Now what happens if the exponent is higher than 2? Well, that means expand for longer, right? How high exponent could be? Well, we could force it to be any number we want. For instance, 1497 dx. It's just fine. The little issue with this is foiling at that point, which would take a little bit longer than before. Much longer. Okay, fine. So what do I do? Well, instead of sitting down and computing all of this, I said, would there be an equivalent, much easier problem that I could solve? And you say, I know if all of this here was to be one variable, I would be able to do this in a heartbeat, because it would just be plus 1 divided by the same number, and I'm done, right? But it's not. So let's try and do that. Let's write some new variable u to replace x plus 3. Now, if I'm to go into integral and put that u in, it will look like this. But now the issue is that I can't put dx. You see, the dx corresponds to integral being computed with x variables. But now I'm changing a variable to u. Well, the common sense says that we must change dx into du. And how do we do that? Yes, very good. So take the derivative of this, and that will give us the connection between du and dx. So if I take the derivative, I will get du over dx is equal to 1, and then I will ship this dx to the other side. And in this particular problem, du is equal to dx. Now we'll see all different versions of it. So now look at the new problem. New problem is a simple problem that we can solve just by adding 1 to the exponent. So this is u to the 1498 divided by 1498 plus c. But now we have another problem. The answer is given as the variable u, and we need what? X. Don't forget to switch back to x, right? You can always say to yourself, I don't care about u, I care about the x. and then just replace it. What's funny? Fine. So there we go. So everything has to be in the terms of the variable that you posed, and that the problem was posed in, and that was variable x. So we will be switching back using the same substitution. We are not getting any. So in this purple box here is the substitution pair, u du, substitution pair. So it pairs variable u with variable x and the du with dx. So let's take a look at a whole bunch of, there is no theory here, and all the u sub is you actually work, it's experience. You working out literally 1,000 examples to iron it out. You want a little bit of theory, here you go. U substitution is backwards chain rule. Done deal. So if I want to check my answer, I will have to use the chain rule to take this derivative, and I will get exactly the same back, right? Derivative of plus c is 0, so because c is a constant. In some sense, integration shouldn't be too crazy, because every time you do the integral, you should be able to differentiate and check whether you did it right or not. Integral of x times 3x squared plus 6 dx. Oh, I forgot the exponent. What's a good number?
5.
5 it is. What you could do is expand the binomial 5 times, right? And then multiply by x. Get your wonderful polynomial there, written in 2 lines, and then integrate each single one of those. You could do that. Or you could say, if this thing over here was just u to the 5, the life would be so simple, right? So that's exactly how you figure out what u should be. You pick what you don't like, and you try to replace that with u. So I don't like the 3x squared plus 6 being raised to the 5th power. I would like to have just x to the 5th power. So u equals 3x squared plus 6. Now what's du equal to? It's the derivative of this, which is 6x, and then we'll immediately put dx on this side. You know it will be du over dx, right? And then you will have to move the dx in the next step. So just immediately put dx right there at the end. Okay. So I know that this piece is u to the 5. Look what I have. I have x dx left, but over here I have x dx, but I also have a 6. So I'll have to fix that in one of the 2 ways. See which one feels more natural to you and use that one. Don't force both. So I can fix this in 2 different ways. And to be honest with you, I have a preference. My preference is to fix within the problem. I like to say I need 6 there so that I can have 6x dx, but to counter that 6, I have to put 1 6 in front. This is the way I like to do problems, because I'm visual. In my case, visually, this mess over here is u to the 5, and I have x dx left, I see x dx, I need a 6, I will put 6 in, so now I have 6x dx, but because I put 6 out of nowhere, I have to counter that 6 with 1 over 6, and I put that 1 over 6, we know that the constants can go. Now, you can only do this with numbers. If you are missing x, you can't do this. You can't fix x in front of the integral. Because the integral operates on x's, not on constants. Constants get in and out. So, this is my preferred way. What's the other way? The other way would say, well, what do I have? I have x dx. So let me divide both sides by 6 over here, move, and make it du over 6. When I put du over 6 here, that 1 over 6 can be pulled in front. I'll show that method as well. So what I did here is I substituted and I fixed what I needed. So now it's 1 over 6 integral of u to the 5 du. Look at that integral. A joke. Copy the constant, 1 over 6, then u to the 6 over 6 plus c equals to u to the 6 over 36 plus c, and now we say the sentence. What was the sentence? You don't remember the sentence? And that's the answer. Yeah. Right? Let's go to this. So whatever is given in black here is the original problem. We said we want to make this easy, so we did. And now you have the leftovers. I need the connection between dx du. That's done right there. And you see you have an extra 6. I add the 6 there because I need that. And 1 over 6, I must put that there to counter it. And now visually, 6x dx. Everything that is underlined in blue, 6x dx is du. So all of the blue stuff goes into this one. And this parenthesis is that. And now you have the basic integral. Integrate, and then you have 1 times u to the 6 is u to the 6 over 36 plus c. I don't care about you, care about the x. That's x, and you're done. Emotions, anyone? No? Let's try next example, see how well it sits. Integral of x e to the x squared dx, because we can. What can you integrate? Let me try to do it this way. This is the way I did it. What is bothering you in this problem? E to the x squared, right? But it's really that e to the x squared bothers you? I don't think so. Try to pinpoint it more precisely. What is exactly the thing that bothers you? It's x squared. Very good, Jesus. It's x squared. Search your feelings. It is x squared that bothers you, not e to the x. You know how to deal with e to the x. It is x squared that bothers you, that it's not x, right? So if you search your feelings carefully, that is the exact thing that bothers you. So for these problems, try to find the exact thing that bothers you and replace that with you. That's what we call the gut feeling for you, Saf. Obviously, if you make the problem worse, well, that was the wrong choice. Reassess, right? Try something else. But in general, try to deal with Try to deal with it that way. What bothers you the most? Start there. So u is x squared. Because I know how to deal with e to the x, not e to the x squared. So let me do that. And then what's du? 2x dx. Thank you. That dx is crucial. Okay, so now I'm going to use that other method that I mentioned. See if you like that one better. I don't have a 2 in the original problem, so I'm just going to say that 2x, sorry, that x dx, which is what I do have in a problem, x dx, is equal to du over 2. I move 2 to the other side. Du over 2 is x dx. So here's my x dx, right? I have it there. Remember, guys, there are multiplications here. You have to understand this dx is the part of the integral. It's the width of the rectangle. This dx is an extremely tiny number. It's a number. Extremely, extremely tiny. It's approaching 0. That's what it is. It's this dx. So there is a multiplication in front of it. It is not natural to write it, but integral of e to the x squared times dx times x. I don't know. It's just weird to write it this way, but I have to stress this idea that this dx is as important as e to the x in the integral. Because e to the x gives you the height, and the dx gives you the width of the rectangle. So this dx is extremely important. As soon as you stop worrying and writing it, you are losing the basic concepts of calculus, and then there is no more calculus at that point. This dx over here, extremely important. So this dx here, when you differentiate, extremely important. Because you see what's happening with du and dx's, right? They're just getting divided by 2 and multiplied by values. They're numbers, right? So now I have x dx. X dx is du over 2. So let's go. Integral. I'm copying e as is, and the x squared becomes u. X dx is du over 2, and in the next step, I'm going to pull that 1/2 in front of the integral and just have this. So this is a different way of dealing with missing constants. I needed that 2 there, so I can either fix it by putting the 2.5 in front, which will leave me there immediately, or you can say, what do I have? X dx? Peel this one off, du over 2, plug in d over 2, and then pull the 1/2 in front. Whatever method makes more sense to you, use it. So now, what's the integral of e to the u? So if you want me to speak like you speak, when I ask what is the integral of e to the u, and you go, I can teach that way as well. Ooh, I can do even worse. I can teach in Serbian. Good luck. Oh, I use it anytime when I can't, when a classroom gets out of hand, I start speaking Serbian, and everyone's like, the hell just happened? Dead silence. Next example, because we can. Now this one is all u. X squared cosine of x cubed minus 10 No, you got this. Dx. Go. You can do it. Yeah, I'm not going to check your answers because all you need to do is to take the derivative. If it works, it works. That's, you know. No need to check with people sitting next to you or anything. You're 100% self-sufficient in this case. You do the problem, you take the derivative. If you got the problem right back where it goes, you're good to go. Now, and I'm going to demonstrate that now, because I'm awesome. Is the stream going? Yeah, stream's going. Hey, hello, viewer. Yeah. No. Apparently, class wants you to leave a comment. All right.
Something funny.
Shisharka.
No, I was saying to them.
Oh, they can't speak. They can just watch, like a TV. Oh, they can type though in chat. Yeah. It's not a two-way. U equal, well, I'm looking at the problem, and I say x cubed minus 10 bothers me. So u equals x cubed minus 10. du is immediately 3x squared dx. Now I like to fix numbers, so sue me. 3 and 1/3 in front. I mean, don't sue me because. And then we have 1/3 integral, and I'm going to do the blue again. So these two put together, remember multiplication is commutative, I can put this in any order I want. So 3x squared dx is going to be the dx, and then I have the cosine u in front. So that's 1/3. Integral of cosine u is sine u plus c, and then we just write cosine of x cubed minus 10 divided by 3 plus c. You can do 1/3 times cosine or everything over 3, whatever your heart desires. It's calculus, supposed to be happy. Not the cosine, sine. What? No, I found it. Now, I'm going to check this. Take the derivative of 1/3 sine x cubed minus 10 plus c. I copy the constant, 1/3. The derivative of sine is cosine x cubed minus 10. And then I take the derivative of the inside, which is 3x squared as a chain rule. And the derivative of plus c is 0. And I see that 1/3 and 3 cancel. And there is the x squared cosine, exactly the same as what the problem had. So, yeah. Yes? Well, this method doesn't solve every problem under the sun. There are another 5 techniques in calculus 2. This is just the most, I would say, frequent one. But there will be trigonometric substitution, integration by parts, integration by partial fraction decomposition. There will be other methods of integration. So this method works, and this is the time when I'm going to stress this part for those of you who are still struggling. This method works when you have something that I like to call function derivative pair. So what do I mean by the function derivative pair? Well, let me go back to x e to the x squared dx. How many functions do we have on a pile over here? 3. I see 3 functions there. There is a function x that could be on its own. There is a function e to a function, and there is a function x squared. So there are 3 functions here. There are 2 functions that are multiplied, but e to the x is a composite function. So how many choices do I have for u? I actually have 3 choices for u. U could be just x, u could be x squared, u could be e to the x squared. So there are 3 different choices for u. Now, remember when I said search your feelings for whatever is that bothers you the most. In this problem, when I look at it, I say, I know how to integrate e to the x. I can't deal with e to the x squared. Therefore, x squared is bothering me, because it was just x. That's simple. So, if I say this is what bothers me, that's the function, do I have its derivative pair? Because the whole method hinges on the function derivative pair. Why? Well, because of the chain rule. function, then derivative, right? You integrate differentiate the function, and you put the chain after it, right? So the same thing goes here, just backwards. So now, I'm looking at this, and I say, do I have function derivative pair? Now, this is going to be extremely important in Calculus 2. Not in Calculus 1, because every question that I ask you right now that it's not a basic integral, like what's the integral of sine, and you go negative cosine, right? Any integral that I would ask on a final exam, it's clearly going to be this, u sub. You just have to figure out what's u. But what are you going to do when you are sitting in Calc 2 in Chapter 7 exam, having 5 of different techniques to choose from? This is where you go and say, do I actually have function derivative pair? Because if I do, I get to use u sub from Calc 1. If I don't, then it's something from Calc 2. So it's going to be very important, this phrase, this wording in Calc 2 to survive Chapter 7 and then later. So I just want to show this one. So function derivative pair, and this function will always be u, and the derivative pair will be a modification, right? It will be du. And in this case, I'm going to circle the two guys. I know there is e floating around, but that's what it is. And now I'm just going to say, here is your Calc 2 question. This question is Calc 2. All right? Calc 2, integration by parts, 7.2. Look at them. The only thing that it's missing here is the square. Completely different method of solving. We have to use integration by parts from Calculus 2. And they almost look the same. Now, why is this one not solvable by what we just learned? Because there is no function derivative pair. Derivative of x is 1. That's x. Top block, right? And there's no way that you can make u sub work with this problem, which means that u sub cannot solve every problem under the sun. We don't need for Calc 2, or half of Calc 2. So you go in and you try to figure out where's the function and then where's its derivative. That being said, let's see. Integral of ln x to the 9 divided by x dx. Now, actually, I should have, let me write this the proper way. Just like trig. It goes right there. Let's see what you come up with.
some notifications that went off with my class started. Oh, we have 14 classes out here outside. No, three times. Yeah, there is. Yeah, the first time, Thursday, and then whatever mid-time that all do, today. So 3 times, 3 hours. I'm going for the fourth one. We have to talk about the final, guys, in terms of time and things. So I shouldn't have been done with this problem, I guess.
Actually, no, we'll talk later when we finish with the section. It's calculus class, supposed to be just happiness. What is u? ln of x, yes. So u is ln x, and what's du? It will come in. So now, here's a peanut. That's the peanut, all right? So we got the peanut right there, and that is our du. Clearly, ln x is ln x to the 9, so u to the 9. And the entire problem quickly collapses down to u to the 10 over 10 plus c, which is 1 over 10 ln x plus c. Here's your next big question. Remember how tangent x is not the basic integral, right? Integral of sine is negative cosine, integral of cosine is negative sine, but then you have the integral of secant squared is tangent. There is no integral of tangent on the list of the basic integrals. Why? Because it's not basic integral. That's the answer. So now, how do you integrate tangent x? Do you see a function derivative pair? Is it there? Is it? Rewrite it. Why? How? Very good. Is there a function derivative pair? Yeah, because sine is derivative of cosine, or cosine is derivative of sine, whatever way you need to. So first step is rewrite this as sine divided by cosine, and sine x divided by cosine x, and then
make your solution.
I'm gonna zoom in. I have that. It's to the 10th power right here. See, look. You see that 10 right there? Clearly, there is a 10 right there. Just that the resolution, you know, it's not that. It's the issue with the resolution, and as soon as I zoom in,
So clearly, Microsoft doesn't have some intelligence. No. On a tablet looks perfect. If you were looking at what I was looking at, yeah. So let's just, if you probably are wondering which one to pick, sine or cosine for you, right? And there are two combinations. I know it's so difficult, just try them all. It's not that there's 17 of those. So it's clear which way it has to be to me, because experience, right? You're learning. So you will have to try one, and if it makes no sense, then clearly it's the other one. And there is a reason why one has to be here. But let's see, try one, try plugging in, makes no sense, then do the other. Inside there is that thing that's wrong, but also desire to be right. And that is because you're learning. There is a difference between judging the way you do it and judging the way you want to do it. Like you being wrong, get that wrong. That's how you perceive it. That's what separates instructors from those who don't. Those who have no ability to see. You know how many times I learned to feel or follow people? I'll make that work. No, that's the one for oh. Congratulations. Well, tough luck. Let's see. That didn't work. I was like, can I make this what we do? It's hard. One or the other. Okay, now the next part, as you are choosing this, I will just make a point of your du and dx are always in the numerator. They can never end up being in the denominator. That gives a clear choice as to which one has to be u, which one has to be du. Du cannot end up in denominator ever because you don't calculate area of the rectangle by saying length divided by width. All right. So du and dx must always end up in denominator. Numerator. Therefore, that gives you immediately clear idea of which one of the two has to be u, and then one that stays behind for du. So to solve this problem, we are going to say integral of sine x over cosine x dx. And then, as I mentioned before, I know that the derivative of sine is cosine, derivative of cosine is negative sine, which I can fix. So either one of these can be u, because they both produce the derivative. However, if I pick sine as u, then the du, which is cosine, ends up in denominator. No bueno. Therefore, u equals cosine x, du equals negative sine x dx. Have to fix the negative issue there. And I get du over u, which is negative ln of absolute value, has to be there, u plus c. Now we say I don't care about u, care about the x, which means bring back the x. This negative 1 can go in as the exponent of cosine. For the final answer, well, and I really hope that you didn't expect anything else other than a secant of some form. Because if you pay attention, when I talked about it 100 times before, trig functions in calculus are paired, always paired, sine with cosine, tangent with secant, cotangent with cosecant. And here it is, tangent secant. Yeah, I know it's not a line, but trig pairs. So by looking at this, you should immediately tell me what is the integral of cotangent without doing any work. Common sense. Cricket. Why is it that?
That will be an exam.
Well, now it will. All right. Next question. Yeah, I know I didn't answer the question. I won't. Ooh. This is what we call a gift question. And if I could draw a nice bow, I will. I would, you know. I don't know if I can draw. It's going to look like a bone.
That's more like a boat.
Is this a good one?
Color in the middle, solid. Yeah. If I show you how to draw a bow, can I pass the class?
No.
Here, what was the answer?
The answer is obviously sine to the 11 over 11 plus c. When you get to clear the clutter out of the site, you can answer these questions just by looking at them. But as I said, you're
learning now, so it's gonna take some time.
Can we not play sports? Let's say dodgeball.
Allison, you want to do this problem on the board?
No, thank you. The guy in the back wants that.
No. Or you can write on the board right where the projector is. Look at that. You? Are we all 100% clear on what happened here? Yes?
Yes.
So sine x, and why sine x? Because it had the exponent 10. Could we do the problem with cosine? No, because the derivative of cosine is negative sine, but you have 10 sines. You don't have one sine, you have 10 of them, right? So we pick sine to be u because we have exactly one cosine. These problems will be greatly expanded in calculus 2, the trig portion, because you can have sine to the 10, cosine cubed, let's say, that will be one of the cheaper problems. And then you see a cosine cubed, and you say, oh, well, I only need one. This is how well you have to know this section to survive there. You have cosine cubed, this stays the same. And you say, okay, I can only have one cosine, which is what I need for du. Which means the other two cosines have to go away. And then you say, oh, but there is the Pythagorean theorem
that the cosine squared is 1 minus sine squared, you transform all of those remaining ones into sines, and then you distribute all that stuff, and you leave one cosine, and then you do this problem twice, because you would have sine to the 12, and then sine to the 10 as well. So these problems get upgraded. If you're taking Calc2, this knowledge must be there 100% walking in the class, so it can be upgraded in the next one by putting a power here. And then when both are even, then just hell. Have to use power reduction formulas and things. All right. So I will write this solution quickly on the tablet for the notes. And then, so good job. Good job. And then I'll take a look at maybe one more example, then hit the break. I will start with u equals sine x du is cosine x dx, u to the 10 du, 11 over 11 plus c, 1 over 11 sine to 11 x plus c. We haven't done any square root question. I mean, it's simple. Here's the awesome question that you can bring up on the next social gathering you might attend.
So how's your function derivative pair going? Do you see something that could be a function and then its derivative? Yes. What's the derivative of dx? And what's the derivative of x? And what's the derivative of minus 4? So you see that the whole thing here has a derivative right there. Immediately you know. The whole thing is a function, that's u, and then this is a leftover for du. So you will be integrating integral of square root of u du, which is we have. This is the answer. Ow. So u is e to the x plus x minus 4 because du, observe the correct use of parentheses here, because it has to be multiplied by dx. You must have those parentheses there. Otherwise, gods of mathematics would be very displeased with you. It will look weird, but it will be correct. I'm going to write every single step. And that's it. So we'll stop doing this for now. We'll go with the break and then lab and stuff. And then we'll do this again later in a day. So we'll here all day anyway. Bye, stream.